Welcome everyone to the 10th Modding Bootcamp. This is the third installment of our animation workshops. In this bootcamp, Modding Supervisor Mario Enríquez will go over the advanced features of scripting animations in Infusion. Take it away, Mario.
Okay, welcome to the next bootcamp. And in this bootcamp, basically, we're going to continue from the previous work that was done on the other animation bootcamp, specifically the animation bootcamp that was done previously. So the one with Theo. And Theo mentioned kind of like a sneak peek of what is to come on this one, on his. That was basically making a custom reload that is not quite like any other current reload in the game, so you cannot use override an already existing reload. So you are required to create new behavior, new player mechanic for it. So we are going to go through the process that is going to allow you to actually implement this into the game. And what we are going to implement in the game is basically this reload. So it's the typical cool reload where you just snap the magazine while you are snapping the other one. And currently, if you want to do this, there is multiple ways to do it in Infusion. And there are some that are a little bit complicated, and there are some that are a little bit more simple. So in order for like not complicate this too much, let's go to one that is kind of like in between these two. And in order to implement this, we are going to have to modify two things. One is that we are forced to modify the weapon itself, so we are going to have to mess with it, but also we are going to have to mess with the player mechanics so that we can introduce the new reload type. So let's go ahead and workbench and start implementing it. This is the project that Theo was working on, so we are going to continue from this. But instead, I'm not going to modify this project. I'm going to have this project as dependency of my new one. So let's create a new project and let's call it Animation Bootcamp 3. And let's make the previous one as dependency. So let's wait for it to open. Let's go first to the previous work that Theo did. So let's go to the animation editor and let's open the workspace that Theo created for us to work on, which is AK-74 Tactic Cool. And in here, what he did, it was two things. One is that he created and imported the animation for this reload type that was just show there. And that's what you can see here. So he created a new line on the reload group so that we can then use it on the graph and play the reload animation. And if we go here to the graph, he also implemented in the reload state machine, he implemented the states for the tactical reload that we are going to be implemented in game. So this by itself is just the animation logic. This will not play anything in the game, especially since we are adding something new that the game doesn't know how to call. So the game knows how to call everything else that is already here, that is existing already here, but it still doesn't know how to call this new logic that we created here. So we need to implement that in game. And when you are going to do mechanics for anything animation related in the game, there are two counterparts here. There is the animation logic, and then there is the script or game code logic. And these two are kind of like hand to hand, but there is some differences in how one connects to the other. So if you wanted to, for example, implement a new character and you created a graph for the new character that contains all the animation logic, how things should play, when, etc., how things should blend, basically what was explained in the previous bootcamp. Then if you want to actually have it be implemented in the game as a new item or a new character or whatever, then you are going to have to tell the game to load this animation graph. And also you're going to have to tell the animation graph how it should be played. So it will be through the controls that we set in the previous one here. So basically, you're going to have to fit the context of the animation graph that is running on whatever entity you set it on. And you're going to have to tell it like which variables to change here from between the script logic, so that then it starts performing the logic that we set in the nodes here. So there is a communication from scripts to the graph, but there is not really communication from the graph to scripts. So it's kind of like one way. So if you wanted to modify something in scripts through the animation graph, then you are not going to be able. The scripts are isolated from the animation graph. So the only way that you can change something in scripts is through scripts alone, and that's it. There are ways to, for example, signal from the animation graph to the scripts that something in animations happen. So, for example, let's say that you start reloading and you want to tell the script specifically when to spawn a magazine on the hand, so that then it can be like seen physically. So the way that you will do is, for example, if we go here to, let me make this lower. If we go here to like this animation, you will see here that we have the events. We can also see it here in the properties tab. And here you can see multiple events that are set in specific frames, so that whenever they are reached, this event gets signaled. And these events are going to be useful not only for the logic here in the graph, but it's also one of the only ways that we can communicate to scripts that something happened in the processing of the graph. So on script, we are going to be able to have a method that is called isEvent, for example, where we tell it what event we want to check for, and then it's going to return true whenever that event has been fired. So let's say that we were reloading and this event was already reached. As soon as it gets reached, we will get this event to be showing on the script inside as true. So then we can perform something like, for example, spawn the magazine on the left hand of the character, so that then it can be seen as if he was reloading it with it on it. And then we can have another one which is attached magazine, so that we can, in the scripts, actually make the magazine that is on the hand of the character actually be an attachment of the AK, for example. So there is this kind of communication there. So the way that the animation graph is going to, in a sense, be able to affect the scripts is going to be in an indirect manner. And basically it's just being the script reacting to what the animation graph currently has. So that's the only way to affect scripts from the animation graph, and that's something that we are going to be using. So in order to make this reload that we were showing here, what we are going to do instead is that we are going to reuse the logic from the game for the normal reloads, and we are going to make it so that the magazine that is here, it just drops with physics. So we are going to make it so that it drops exactly in this point, which was already marked by Tio as weapon detached magazine here. We are going to listen to this event on scripts and actually make the currently attached magazine to be detached and drop with physics. And then we are going to continue to the normal reload. And in order to do this one, it's actually going to be a little bit interesting, because we, even though here we only modified one graph, and that's the graph of the AK-74, we are going to have to deal with two graphs, because part of the logic of reloading is actually on the character, because that's the thing that is causing the reload. So we are going to have to set the inputs and all that for the graphs through the player controller. And then we are going to have to do some changes as well on the animation controller of the AK, so that we can listen to the event, because the event is going to be fired by the logic of the AK animation. It sounds a little bit complicated. It sounds like it's going to be a lot of scripting, but it's actually going to be quite simple. I swear it's going to be simple. So let's start with that. So let's go to scripts. Let's see the things that we need to modify. Or actually, let's go first. I think it's better if we do it visually. So let's go first with actually like detecting first which prefab we have to modify. Right now, in the way that TO made it is that this animation graph is a new animation graph. We are not overwriting, we are not modding the original AK animation. So let's actually, instead of overwriting the animation graph, let's just swap what the prefab from the AK is actually reading to. So let's make it so that instead of reading the vanilla one, it's going to read our new custom one. So let's first locate, let's go to World Editor. And let's first locate the AK prefab. We can just search here AK, but it's going to show us a lot of other resources that are not just only the prefabs. They can be audio or whatever. So let's limit the search a little bit by pressing space, which is going to make it so that it's another keyword that is going to be searched, and make it so that it's going to search instead for .et, which is the prefab. Let's do AK74. So we are going to see here multiple. These are not loading, or well, it's taking a bit to load. And let's take the base of the AK74. So on this one, actually we'll open a world just to be able to set it there. And no, actually let's do this one, and then drop it to the world. I made it so that it creates a new subscene, so we can modify it, because we are going to use this world later for testing. And here you will see on the right side the components that it has. If we want to change the animation graph that a prefab is going to be using, in this specific case a weapon, then we are going to need to find the weapon animation component, and we can just look through the list here and find it here, or we can just filter it directly by typing weapon animation component. And here we want to make it so that instead of pointing to this animation graph, it points to the new one that we created, and also make it so that this instance, it points to the other one that we created that has the animation that you created. And same thing for this one, and same thing for the player version of that one. So let's go instead here to, actually let's go here, and then right click on it, and then do an override in our new animation bootcamp project. So once we override it, we are going to be able to see it here as well as a variant, or in this case, inherited prefab, that is going to, in the end up being the same prefab. So let's go to Animation Bootcamp 3, and let's make the changes that we want here. So here we click in the three dots, and then we are going to be able to choose the one that we want. The one that we want is in Animation Bootcamp number 2, and it's this specific animation graph here. And let's change the ASI as well, the animation set instance of the weapon, to be the new one. And same thing here. And same thing here. So now we can just save. Let's save the world as well. Let's be lazy and actually no, let's just create a new folder called worlds, and let's save it here as nptest. So now this normal game prefab, it should be spawning with the new change that we did. We can see here by clicking here to find it, that is loading it from the ones that we have. Another way, if you want to see if your changes were saved and all that, way to checking it here, another way that you can do it is to find it here, like in the resource browser, go to the prefab that you want to check, and use middle mouse click on it. It will open it here. Then you can do view and then text view, and then you can see the text representation of the prefab here, and you can see if your changes are done here correctly. Because sometimes, depending on what you are modifying and how you are setting it up, the world editor might be cached, and it might not represent the changes that you did. So if you want to be sure, without having to reload the whole world, if you are modifying it through there, is to just open it here and just check it this way. So now that we have here with the animation plate and all that, let's just save and try to play it in game and see if we can do something with it. Like, let's see if it didn't break, if it's going to still work. It should have spawned somewhere else. Let's see, where's the spawn point? There is... I don't see a spawn point, so let's go here and play from current camera position so that we don't spawn somewhere else. And play. Okay, so we can equip it, no issues. Nothing has broken so far. We can shoot it, that's fine. So, because we affect the reloads, let's spawn a magazine and see if it works. So let's go through here, Arma Reforger workbench, and then we go to prefabs, and then we can go to weapons, and magazines, and then let's search for the AK one. So let's spawn this one. And from now, let's just spawn like a bunch of them so that we can keep reloading it. Let's save the world so that they stay there and play from here. Let's equip it. Okay. Let's see if we didn't break reload with our changes. Okay, still reloads normally, but you can see that it is not reloading with your custom animation. So we need to tell the game now that we want to reload with our custom animation. And remember that in our case, we didn't want to just replace like the existing animation. We want to create a new type of reload so that you can still have the old reload, but you have this new one as well. And the way that you have to do it first is that, well, first you have to think how you want to do it. And when I was discussing it with Theo, we decided to just make a new type of reloads and just give it a different index of the reload type, that then the animation graph is going to receive this index, go through the correct path in order to play it, and then just play the animation. So that means that we are going to have to affect the logic in the game, so in the scripts, of what type of reload to issue, so that then it can be played on the animation graph correctly. So if we go to the animation graph, close the animation editor, let's go here. Let's open the graph. We can see here in the animation graph panel, we have multiple nodes here, multiple states and all that. We are interested in the reload ones. And the reload ones are actually, you can be found here. So on weapon reload STM, these are the new ones. So if we want to see, for example, which one is the one that ends up being entered, you can see here that all of them, they are starting just by the value, like if they are true, like it was explained before by Theo, that whenever you enter a state machine, the state machine is going to try to enter which whatever one of these is going to be true. And if none of them are true by default, or none of them are set to have a start condition or whatever, you know, if all of them are empty, then the one that is going to be taken by default is the first one in the definition list. So the first one that was created when you were setting it up. But in this case, all of them, if we go here to properties, all of them, they have start conditions. So as you can see here, like they all change and the start conditions are set to something to all of them. So all these nodes, they are start nodes. So the ones that we are interested on are these ones, because these are the ones that play the new animation. So if we click here, we can see that you made it so that whenever the command weapon reload command is issued, it's checking not only if it was issued, but also if it was issued with the integer 10, which is the index type of reload that we want to do. As you can see, like this one is different, one is like 5, or also checking the float value is 0 as well, etc. Checking if it's 4 here, checking if it's 2. And this one is 10, so remember this, because it's what we are going to use. Okay, so now that we already have told the prefab to use the new graph, the new animation set instance and all that, now let's just go now to scripts. And remember, right now we are affecting the reload type. This part of knowing exactly what to modify and when is a little bit tricky to figure out. So if you don't know already where to start, just go to the Infusion scripted channel and ask there. Either one of us in the company will answer to you, or it will be another modder that already went through this. In this case, thinking a little bit of what will be happening might be good. So if you start thinking, okay, I'm a player, I want to reload in a certain way, think about first what could have caused like the weapon to reload, okay, the character. So most likely let's search on the character controller and see if there is something to handle reloads or something to perform a reload. So if we want to see, what the character has in order to be able to perform logic, we can go to the character here in the prefabs. Let's do ET as well for the prefab. Let's load any character. Let's load, I don't know, like this one. And we might want to find a controller or a handler or something, or even the animation stuff. So let's do, for example, command handler. So let's do handler, and then we can see here that we have animation component that also has a character command handler component. This command handler component is actually very important because when it comes to performing the logic of the animation graph and the script and all that for animations, the command handler is the one that actually represents the actual state on the script side, and this is the one that is actually controlling directly how things should be played in the animation graph. So it's the one that is actually performing the state machine changes and all that. So this one is important. You would think that it could be the character controller, but the character controller is more for inputs. It's more for logic with other systems in the game and all that. The command handler is specifically to control the inputs that are going to affect the animation graph. And it's also to control the states or the performing of the states that the animation graph is going to be basing its logic on. So let's click here, or let's do right click and then jump to script definition. We are going to see this class. It's a scripted class, as we can see here, which means that we can modify it and we can like make things perform in different way by modifying it as seen in the other previous bootcamps. But I'm interested here to try to find where to actually embed my logic. I want to embed my logic when I'm performing the reload. So I'm hoping to be able to find a reload method or something similar. Here we cannot see anything like that. If you don't want to just be reading through this in order to find the methods that are available, you can just do window and then you can just enable outline. And then in the outline, you're going to be able to see what things are present there. So I don't see where here's the outline. And here we can see with things that are M, it means method. Things that are UB is variables. So we can see here that we don't have any method that is interesting for us. So let's go one inherited class deeper. And here we can see multiple more methods. And still we don't see too much of something that might help us here. Like we see start command file, start command ladder. We don't see something for reloads. But if you read through here, or like if you search here reload, you will find two things. You will find handle weapon reloading default method, and another method that is called handle weapon reloading. These two methods, it might look like they are duplicated, but they are not duplicated. The thing is that this method, as you can see here, is an event method. So it's a method from C++ that is going to be called in C++, but it's provided to you here in the interface so that you can then override. So that means that you're going to be able to embed logic into this, and then it's going to be called from C++ like if it was a normal method. And whenever you see some method that has event.init from C++, it means that you are going to be able to modify it. If you were able to see some method like this that only has proto external or proto or native or external, but it doesn't have the event thingy, then it means that it's not modifiable. So it's just going to be a method that you can call and that's it. If you see a method that only has the return type and protected or whatever, then the rest of the signature, then is a scripted method that usually means that it can be modified. If it has sealed, then it means it cannot be modified. So here you can kind of tell if you didn't have documentation, for example, of what could be like the intentions here. Like these methods that you see here, they are events. So that means that they were exposed for you to be able to overwrite and change the behavior. But the connection that this has with the proto ones here is that, for example, the weapon reloading event here, if you modify it alone, you will see that it will perform some logic whenever you're trying to reload. But if you don't do anything else other than your own logic here, you will see that it breaks reloading. It doesn't perform the actual proper game reloading. And that's because the way that this is made is that you call this method perform your logic, and then at the end or at the beginning, it depends what you want to do, you have to call the handle reloading default if you want to handle the reloading by the game. So we can test this right now. So let's modify this class that is here because it's already there. We want to modify it for all players. So it's fine to do modded class and then this. So let's create a new script file. We can see here, let's search for it. Character command handler. So we can see the ones here, command handler, that's not this one. When you want to modify a class, you have to create a new script file, or you have to add your modded class in another script that is already defined somewhere. If you try to do it kind of like in prefabs, and you do, for example, right click and then duplicate to or overwrite into something, what will happen is that it will ask you to create a file name, and then when you click OK, it's going to create the same directory but in your project and create a new file with this name. So if we were to do this right now, don't change anything else, you will see that now your game is not going to compile, and it's going to complain that, oh, there is certain issues here and there. So let's try to compile it. And if you see here, let's see, like open this one, it duplicated the whole file with the same directory, as you can see here when I'm hovering. And you need to be careful with this, because if you do this, it means that you are not modding the class. You are completely overwriting the vanilla file. So whatever you write here is going to be taken as the original file. And that's not what we want. And that's also a common mistake that many people do when they are figuring how modding works in scripts, that they create this file, then they modify it, then it says, for example, they are thrown with error that the class that they're trying to modify doesn't exist. And it doesn't exist because they replaced the whole file, removed everything in the file, and you just added their modded class, which removed everything. So in this case, we actually want it to be different name. So let's call it custom controller, custom character handler. And then we are going to be able to see here in scripts again. We can open it here. The original one is still here, but now we have this one that has everything from the previous file because we duplicated it. And so now we want to remove everything and just do modded class and then the class that we want to modify. And then it will start compiling, no issues. And for those that were not there for the modding bootcamp number 2 or have not watched it, the way that you add things to classes when you want to modify it is by creating a new class that starts with modded class and then the class that you want to modify. And what this will do is that whatever you define here is going to be now part of the original class. If you're a little bit interested of how it works, the way that the compiler compiles these classes is that first you have the original class, which is this, for example, and then you have a modded class of your class here, and then let's say another modded class from another mod. What the compiler is going to do is that it's going to take the first class, append a number to it, so let's say 1. Actually, what it appends is like a hashtag and then 1. And then it's going to make the next modded class to actually inherit from the previous one, which was the original, but with number 1. And then when it detects another modded class that wants to mod the original class, then what it's going to do is that it's going to take the previously modded one and it's going to append to it the next part of the index, which is 2. And then it's going to make the newly modded class. It's going to keep the original name so that now it gets treated as the original one. And it's going to make it so that it inherits from number 2. So that's why modded behaves exactly the same as normal inheritance, because it's behind the scenes doing normal inheritance. It's just that the class that you end up with is the same class name as before. But internally, this here is what's happening. So that's why super works, and that's why whenever you have super of a method, it calls the previously modded implementations as well, if they didn't ignore super as well. So that's the general idea with modded classes. In this case, as we saw here in this one, we want to override the handle weapon reloading. So let's just copy the entire method signature here, paste it here, and make it so that now it has a body. Notice that I removed the semicolon. And then here, if we just have it like this, it's going to complain that the method is already defined, so we are not really overriding it. So we just add the override, which is going to allow us to override it like in any other language. And let's also call super so that if some other mod were to mod this, then we don't break their behavior. So let's just propagate here the call. And then here, well, let's return something. Right now, let's just return true to tell it that it was processed. And here, this method, it will get called whenever we perform reloading. If we want to test, then we can just do a print here. And the print, it was called. And then let's see if it prints whenever we reload. So right now, let's check if it compiles. You can test if it compiles by pressing F7, or you can go here. You can go to build, and then validate scripts. But validate scripts use validates. It doesn't compile the whole thing. The game is not going to suddenly start taking it. So if you want to do that, you have to do validate and reload scripts. But right now, Workbench has a default setting that whenever you change a script file and then you unfocus from the script editor, it will perform validate and reload for you. So you can see it here, for example. Like if I open the Word editor and go to Word editor, it will perform the reload. But for me, that's a little bit annoying because sometimes when you are just modifying things and you are going to the animation graph to reference something or whatever, like right now, it will automatically compile and reload things, and then things will break if you left something in the script editor unfinished. Or if you have here like a more complicated world, like the Eden one or like the Arland, it will make the whole world reload and it will take forever. So I actually find that feature quite annoying, so I prefer to disable it, and I recommend, if you know what you're doing, to disable it, because it can become a pain. So in order to disable it, you have to go to Options, the Workbench, and then untick this Auto Rebuild Scripts, and then click OK. So just remember to, whenever you want to test, to actually validate and reload. So in this case, we want to test this, so let's do validate and reload scripts. And then go here, let's remove this character. And right now we are modifying everything. So because we are modifying the character, so that means that this is going to be called on the reload of every weapon, because it's on character level. So let's play. And let's some tip: if you want to see in the game, like the console, the script console, you can press Shift and then tilde, and it will open this so that you can see what's being called. So let's reload, and we see it's like Workbench caching the things, as I mentioned before. So this can be a little bit annoying. It can make it so that sometimes you think that something didn't work. So what I prefer to do, to not be having like the issues with Workbench caching things, is that I prefer to test in dedicated server environment. And we have a tool here actually that you can go to settings, plugins, and then run dedicated server tool. And then this is going to run a developer version of the server that Workbench is going to be able to hook into. And it's also going to run some peers, so another clients that then can connect automatically to the developer server, that then you can also connect Workbench into. So you're going to be able to debug the animations that are playing, debug the animation graph, runtime simulation on these clients. It's going to allow you to see if your logic is performing correctly, or try to figure out where to modify things. So it's pretty useful. So I will teach you here as well how to do it. So first we have to set up the settings. And here the settings that I use is that here in the config I select the CLI server. And in admin password, this is if you want to use GM or something. Right now, just choose any password, A. And then in executable, you have to provide the server executable that is going to be used to run the DIAG. In this case, we are using experimental. So as you can see here, we are going to use the experimental server. But this is quite important. You can run it with both, but we want to connect Workbench to this server so that then we can debug. So the only executable for server that you're going to be able to connect Workbench with is the diag one. So we have to use the diag one. And this also places a limitation on the kind of clients that are going to be able to connect to this server. Only clients that are going to be the normal game, but that end with diag, are going to be able to connect to diag. So diag cannot connect to normal server, and normal client cannot connect to diag server. So it's isolated, so don't worry about hackers or things like that. You are only going to be able to change things on the runtime and all that if you are in the diag environment. So let's go again to server, select the server here. Profile, let's just leave it as default. And let's set the params here. We want to connect Workbench to it, and the way that Workbench connects to it, specifically the script editor, is that it connects through a network socket. So it's going to ask us for a port, and in order to tell it what port is going to be run into, we do debugger port with capital P, and then space, and let's do 777 for the server. And we also need to tell it where to find the add-ons that we are working on. So in order to do that, we have to type here add-ons dir, and then we have to provide a directory. So let's get the directory here. If I click here, I can see the add-ons directory that we created. But actually, not this one, is in documents, my games, Arma Reforger, add-ons. So we need to provide this directory here. There you go. And we are going to have to do similar thing here to the peers. I will make it bigger if someone is following so that they can see. And we want to run with peers, so clients as well. So let's take this and let's provide the peer executable, which is going to be the normal diag game server. There we go. And let's use one peer config for now. And here we don't have to set anything else, it's just the params. We have to do something similar as the server. We have to tell it where the add-ons are, and we have to tell it a different port. Let's use for this peer 666, and then we can click run. If you don't set the world here, then what's going to happen is that this is going to run it with the world that you have open in the world editor. But if you want to specify a specific world, then you can do it here. But if we leave it empty, by default, it will use the world that we have in World Editor. So let's click Run. And let's do yes to all. And let's go here to debug. Then go to Custom so that we can tell the script editor to connect to the new one that we have created. And let's connect to server. So let's do 7777 and click OK. And you are going to see here now that it connected to server. And for example, if we go to remote console here, we also go to, where is the output thingy? Let's see, window. Let's see. Oh, I see, I'm blind, sorry. So here you can see like it's telling you the debugging stuff from the server. So let's clear it. So if we go here and we reload, we can see that now it called what we mentioned here, but it called it multiple times. It called it multiple times because this handle weapon reloading, it gets called every simulation frame. So that's why you see the delta time here. It gets called every simulation frame that the reload is happening, because this is what performing the reload. And you will see that it's the same time that in the animation editor, for example, in the workspace, if you go to the animation graph, it will be called for the same time that the weapon reload tag there is active. So you need to be careful of not spamming the things here. Like in these methods, handle whatever. Just be aware that they get called every simulation frame. So whatever you do, it has to be offensive towards the deltas and all that, so that it doesn't get spammed. In this case, we know that we're able to call this and make sure that it works. So let's close it. In this method, we want to make it so that it calls our custom reload. And actually something very important that I told you before is that whenever you call this, if you want to call the previous normal game implementation, make the game actually perform the reload, as we saw before, this goes hand to hand with this handle reloading default. So right now, if we remove this so that it doesn't spam here, right now if we run this, even though we're calling super, you will see that the actual reload doesn't happen. The animation will be performed and all that, but like the actual reload will be broken. So if we test here again, you can just open this quickly with Ctrl-Shift-D and run it. You start seeing that we actually are not reloading, that things are not working correctly. Like, see, we cannot reload. Like, even if we take this weapon. So let's drop this. We take this. We see that, like, things broke. And the reason why things broke is because the whole simulation of the weapon got broken because we didn't call the handle weapon reload by default. So when it tried to go to this state, the end state of the handle weapon reload didn't get called, which didn't reset the things correctly to the previous state, so now it's broken. So don't forget to call this. Like if suddenly gets broken or you tried before and it didn't work, it's because you were missing to call this. So if we pass the values around, which is basically the same as this, and return this and call it, it will now be working correctly. Syntax error, where's this? Let's handle weapon default. Oh, I have double thing here. Okay. So now we run it again, and the normal weapon reloading should be working now. So yeah, we can see like we can reload now. So let's close this. And let's go here. And now let's tell it to load our new animation. So the way to do it is actually quite simple. You see here that we are being provided like 3 arguments, and one is input context. Another one is the delta time. Another one is the current command ID. And the commands in scripts, they are actually quite different from what you see as commands in the animation graph. Even though they are related, they are not like the same thing. Commands in scripts is basically kind of like, I mean, the best way to explain it is saying like regions of logic that, or state machines that perform specific logic and handle like the command state transitions from the graph. But for example, a command in scripts, a scripted command or jump command or whatever, it could actually be tied to 5 different animation graph commands. And usually these scripted commands are what actually cause the animation graph commands to be fired. So this command ID is not the ID of a command in the animation graph, it's an ID of a scripted command. So in this case, it could be, for example, if we go here, the ID of like the command move or the ID of the scripted one, etc. So you can use it here to identify which command is the one that is actually performing this call. But right now we don't care about that. We only care about that whenever this gets performed. We don't care from which state machine or which state in the game it got called. We want to make it so that set reload weapon 10 gets called. This is not the best way, but this is the easiest way to explain. It's the easiest way to see it. So for now, let's just force it here. When it comes to handling the logic of the animations and the character movement, etc., and the inputs, they are all based in their logic on a general structure that is unique per character in this case. And this structure is the character input context. So all the logic that gets fed to the graph and all that is usually stored through here. And that's why you see a lot of setters and getters and all that. Is because like this is what's being passed around in the animation commands in order to perform or change the animation logic. In this case, we want one that is called like set reload weapon. So if we go here and search for set reload weapon, so set reload weapon, this reload type thingy is what is being used in, we go here again, it's what is being used here. So it's what this number means. So whenever we fire this animation graph command, you usually fire, as you can see here in controls. Let's go to CMD weapon reload. When we fire this, so let's play here. There we go. So if we go here, whenever we fire it, it comes with two arguments. One is the float value. It can be whatever, or integer value. This integer value, whenever it gets called from scripts or game code, is what is being set here. So we want it to be 10. So let's take the input context that is sent here, and then do set reload weapon, and then let's give it 10. No, it should work fine on that. So now let's try to see if the animation graph is actually running it to 10. So let's go back here to the animation graph, stop playing this, and let's go here to the game and open the dedicated server tool and run the game. And actually, let's take this weapon because this is the one that we want to test. So we have taken in hands, let's take the ammo, and then let's perform a reload. Okay, you can see here that it's reloading the things correctly, but it's not taking the previous magazine out or whatever. Like it's just placing it on top and then deleting it. That's because internally in the game code, whenever it's calling the other reload types, it actually takes care already of the previous magazine that was inserted. Because this one is a new one that is not handled by the game code. It's not doing anything to the previous magazine, but lucky us, because we actually want to do something with it. We want to make it so that it drops. So it makes it for the perfect situation where we can control it without doing a lot of work in order to be able to avoid what is happening on the C++ side. So in this case, we are going to make it drop, and we don't have to mess with the core logic too much. So as far as it goes for character, so the character handler component, this is everything we have to do. We are set. But now, if you want to know as well, let's say that your animation is a little bit more not so different from the usual ones. Let's say that it just changes the rotation of the hand or something, and it's hard to see here if it's being processed. Something that you can do is that you can connect the animation editor to a running instance of the game, and then you can see like what paths were being run, and also you will be able to see the current state of the graph here. So you will be able to see what's been set, and also see like what things are being processed and all that, and also change it in runtime if you want to change it. So you don't have to reload the game whenever you perform a change. So let's connect it to like this game here. So the way that you have to connect it is, first you need to know which graph you want to check. In this case, we want to check the AK tactical cool animation graph. So, and we know already that we have a entity that is running this animation graph currently in the world here. So now that we have these two things set, we can go to Live Debug, and here you will start seeing the instances that you can connect to. Right now it shows nothing because we need to actually tell the game to start like sending this data so that the animation editor can see it. So the way that you do it is you press Control, Windows key, and Alt, and then with arrow keys you can go up and down here. You have to go to the animation 1 and then press right arrow key, and then here in Enable Debugger, enable it by pressing either left arrow key or right arrow key. In this case, we already done it. So now, like at some point, this graph and all that, it should start showing. Let's see. Yeah, let's stop playing it. And if it takes sometimes show, if you don't want to wait, you can just relaunch the animation editor. So let's wait here for a little bit to show. If it's not showing, then we can just close it. Same change now, I don't want to shape changes. And go back here, animation editor, and tactical. And let's wait for it to load and go to workspace and set the graph and the weapon. If it doesn't load, probably we messed some settings somewhere, but let's wait for it a little bit. So while it will show, then let's go to the next one. The next part is now to actually modify the weapon so that the weapon now also is going to be able to perform the logic that we want. In this case, we want to listen to an event, and we want to listen on that event on the weapon that gets fired when the reload gets done. And remember that is this in this animation we have here is this event here. So the weapon detach magazine, which gets called exactly as when the previous magazine has to like get detached and dropped. So that's what we are going to listen to. So if we go here to the scripts, and then we are going to have to do another model class. In this case, well, first let's go to the prefab here. We need to get the animation controller of the weapon so that we can gather information about the animation on scripts. So let's search for animation, and we're going to see here that we have animation, weapon animation component, and it's the previous one that we modified. So as you can see here, it's the one where we changed the settings here. So we want to modify it in scripts now. So let's jump to script definition. You will see some issue here. This weapon animation component is provided from C++. Usually you know that by going here, and then you can go to like wherever they are defined. And if they are from a folder that is called generated, then it means it's from C++ and you cannot just mod it. So okay, that poses an issue because this has an event on it, and that is called on animation event. That is the one that we want to listen to. So how do we modify it? Okay, one way is that we can just hard override the file, but that has a lot of issues, and that's what we should avoid on doing. So something that we can do as modders is that you can make a new class that inherits from this, and then just change this class to be pointing to that new class. But the only issue here now is that any other mod that tries to modify this is going to try to do the same and take yours away. So when you find yourself in a case like this, you already saw like a modability issue here, a modability risk. I recommend that you go to the feedback tracker, go to Arma Reforger modding, and create a request where you specify why this is an issue, and tell us that used to make a scripted class that derives from this, and make it so that it's part of the base here, so that then you can just overwrite it with the issues on the script side, and then it's not going to cause other mods to be incompatible with yours because of this. But in this case, for these purposes, let's just change it. So let's create a new class that inherits from this weapon animation component. And let's go here. Let's do it on the same file as the other one. So let's do class and custom weapon animation component that inherits from the weapon animation component. And we want for it to show as a new selectable component on the property grid. So that means that we have to also do like the typical thing of like basically, well, not copying this, but like, let's just copy the same one that is here. Or let's just, to be safe, let's do one that is already created. Let's just steal this one. So let's place it here. So we have to have the data class. It's basically the same class name, it just ends with class. Weapon animation component class, okay. Let's just make custom here. So now this should be able to be shown. Let's validate and reload so that we can use it in Word Editor. And now we should be able to swap this one with a new one. So let's go here to change class. We should see the custom one. Wait, what was the name that we did? Custom weapon animation component. No compile errors. Okay. So what is the animation here? So we want to change the class to the new one. If it doesn't show, just either reload workbench or like try to see if there was an error somewhere. In this case, let's just reload workbench. It will be faster. So let's go to Word Editor again. Let's open the previous Word. Let's go here and then weapon animation component, change class. And now we can see the new one that we created. But remember, like right now we have clicked on it here. And that means that we are modifying it as an entity here. So it will only modify the one that is placed here. We want to modify the prefab. So let's go to the override of the prefab that we have in Animation Bootcamp 3 here. And let's actually change the class here. So change class. Oh no, this one. Weapon animation component, change class to the new custom one. And then saved. And now all the instances that come from this AK prefab or that are inheriting from this prefab, they are now going to have the custom weapon animation component that we made. So we jump to the script definition. Now we are going to be able to modify that method that we wanted. So let's go to the inheritance chain and go to base item animation component. Let's copy this one. And we are going to overwrite it the same way that we overrode the other one. So overwrite and then create the whole thing here. Also, let's not forget the super. In the super, let's call the other things here. Right now, it might sound like it's a lot of work, but it's mostly that I'm trying to explain like all the things, best ways to do something, how to check something. So it's making it us go to the end a little bit more longer. But at least you get some useful information from here, apart from knowing how to do this specific weapon animation reload. So now that we are here, we can do like the logic that we want. In this case, we want to listen to an animation event, which is the one that we had previously. So that means that now I have to introduce you to how to listen to the animation event. So you can see here that you have an animation event ID, but what you had in the animation graph, if we go back here and open this, but what you had in the animation graph here, if we go to reload this one, wait, did I open the correct one? Let's see. Okay. If we go here, we only see some names here, but we don't see an ID. We don't see like any ID that is asking here. This ID is not a string, it's an int. So we cannot see it here. So that means that we have to get it from somewhere. And the reason why you cannot get it from name is because if you try to do this all the time or just pass it around, it's quite expensive. And when it comes to animations, they are processed per frame. They are processed for a lot of things. So passing this as a string becomes too expensive, especially for the amount of entities that we want to have in Arma Reforger. So what we do instead is that when we start like to load the animation graphs and all that, and the animation files, whenever we find a new event that is defined on the animation graph or the animation file, then we start storing it in a static integer array or map. And this makes it so that whenever we see an event that is supposed to be weapon, attached magazine, or whatever, it gets assigned some ID. So now we don't have duplicates for every animation that gets played for every character. And this ID is the thing that we pass around, and then we have to get it elsewhere if we want to know what it is. So that's what the ID is, and that's why it's int, not a string in this case. So the way that we want to get it is that we have to somehow get the ID. And one way to do it here is that we can do it once when this component gets created, or we can do it every time that this gets called. This thing never changes, so we can just do it once. So let's do it on the constructor of this custom animation component. So if we go here, try to search for a constructor so that we follow the same format, we can see that the only constructor is this one. So let's just make the same one, but on our custom class here. When it comes to constructors, you don't have to do override. You just create a new one. Let's do, it has to have the same name as the class. So here we are going to want to get this animation event. And as you can see here, like it's animation event ID. So let's just create a variable here that is protected, for example, animation event ID. And then just call this, let's say, weapon detach or magazine detach event. And then let's just set it here by doing magazine detach event, and then equal game animation utils. And then here we can do register animation event. And then here it asks us for the string. And that string is going to be the name of the event. In this case, we want the detached magazine 2. So let's copy this name. Let's place it here. So now, whenever this is triggered, we can now check if the anim event type is equal to this animation event ID. And in this case, we will check it in an if. And then if this is true, we want to do something. So let's now do that something. In this case, what we want to do when the animation event gets called is that we want to make the magazine be detached and drop. So we are going to perform that here. Something to keep into account is that this animation component, it gets called on every client and also on server. So every client that has, in this case, this weapon stream in or like showing in the vicinity, it can be far away, but as long as it hasn't despawned, this on animation event is going to be called on them. So that means that we can just call the detach and drop it on every client, and we will have no issue. We don't have to replicate things and all that because it's called to everything anyway. So that actually makes it easier for us to perform something on the bands because we know it happens everywhere. We just have to detect it and that's it. We don't worry. So let's create a method now that is going to perform the tactical reloading. So let's do perform tactical reloading. And then let's call this perform tactical reloading here. So in here, like, we want to get multiple things. First is that we want to get the weapon. So let's get the weapon first. So const e entity, the weapon is an entity, so we have to do the entity class. So weapon equal, and this, remember, this is a component, the weapon animation component, and this component was on the prefab of the AK, which is the weapon that we want to get. So we can just do get owner. So the owner of the component, which is the weapon. That alone, like, we already got the weapon through this. Now we want to get the weapon component because we want to get the magazine. And the only way that we can get the magazine reliably is through the weapon component. So let's do const. The const is because we are not changing this value, this variable. So let's make it const because it will be faster for the script VM to process. So let's do weapon component. And let's do weapon. And then we have to get the weapon. Then find component. And we have to provide it the type name of the, which in this case is the class of the weapon component. And we need to cast it to weapon component. And the weapon component could not be there in this case. You can do a check, if weapon component, but in this case we know it's there. So let's just keep it there so that we don't make, for learning purposes, we don't make this longer. And now we need to get the magazine. In this case, we have to get the magazine component first because it's what we can get directly from the weapon component. So let's do const, and then base magazine component. And then let's do Mac component equal. So let's see how we can get the magazine from the weapon component. If we go here, in this level of inheritance, we have nothing good right now. But if we go here, we should have like a magazine something. So let's search here, magazine, get current magazine. So let's call this method. And then let's do weapon component, get current magazine. And now we have the magazine component on it. We want the entity so that we can perform physics on it. So let's also do, again, const e entity, and then do weapon entity equal, and then the Mac component and the get owner. And now we have the entity that we want to drop. So if we want to perform physics on an entity, we need to get the physics component. Sorry, well, you need to get the physics class that is attached to the entity. So let's do const, and this class is just called physics. And let's do node weapon entity, magazine entity, Mac entity. So let's do Mac physics. That's the name. And let's do map entity get physics. Okay, so now let's do what we wanted to do. Remember that we want to, remember this is attached to the weapon. We want to detach it. So one way that we can do it is to do remote child from the weapon on the magazine. So let's do that. So let's get the weapon entity and then remove child. And then here we can see that you have to give it the child that we want to remove, and also we want to keep the transform. And in this case, we are going to give it the magazine entity, and we want to keep the transform. So we want that as soon as we remove it in this position in the world, it stays in this position in the world, because then we want to do something from here. So let's provide it with true here. So now we're almost done. Now we have to perform the physics thingies. In this case, we want to change the simulation. We want to make sure that it's set to simulation, is not set to collider or something that is for statics. So let's just make sure of that. So let's do change simulation state. And here we have to provide the state from a simulation state enum. So let's do simulation state dot, and let's do simulation. And now we want to also set the interaction layer so that we can set it to, for the magazine to, when it's dropped, to actually interact with certain things. So in this case, I want it to interact the same as the Bryce or the Breeze in game. So let's do send interaction layer. And then in here we can do like the enum physics layer presets. Let's do the Bryce. And then we want to enable gravity on it, so let's do enable gravity. So let's set it to true. And now we also want to, like right now, it will just drop. So we want to make it so that when you like snap it like this, snap it out, it also gets pushed a little bit towards the front. And we also want to make it so that it rotates a little bit with some angular velocity. So we are going to perform both things here. So let's do Mac physics, and let's apply the impulse, or let's do apply impulse. And let's apply it from the center of mass. So let's do apply impulse at, and the position is going to be the center of mass. So let's get the Mac physics and get center of mass. And then the second one, we want to provide the direction. In this case, we want to make it sure that it gets pushed from the direction the weapon is facing. So let's get the weapon here. And let's get the third transform axis, which is the forward direction. So let's do get transform axis. Let's get the index 2, which is the third one, because it's indexing an array here, so that's why it's 2. And then let's multiply this by the mass of the magazine. So let's go to Mac physics and get mass. So just so that it gets pushed a little bit to it. Like we don't want to make it so that it gets shot. And let's do the angular velocity so that it just starts rotating a little bit forward, and that's it. So let's do Mac physics and then send angular velocity. And let's just make it rotate a little bit forward. So X, Z, and Y here. And this one is the forward direction. This one is the upward, and this one is the side, so the X direction basically. So if we didn't miss anything, this should be it. So that entire reload type can be done with just this amount of code. It's not really complicated. For some people, they think that performing animations in custom animation mechanics and all that in Fusion is complicated, but it's really not. It's just that you need to know like what things to mess with. So it's a little bit nice first to start like how we started, like thinking what things are going to change or perform the action on the entity. Is it going to be the entity itself? Is it going to be the character or whatever? Then you start working from that. So now that we have this, let's see if it compiles, okay. So let's try it in game. So let's run the dedicated server tool. Let's play it. And let's see if we get like the intended behavior. Okay. In this case, remember like the animation and all that is set on the prefab, so this one reloaded normally. But if we change to the AK, which now has the custom graph and the custom logic, this one should perform the reload. See? Exactly as we wanted. And now because this animation event thingy and the command handler and all that, they get called on like the authority and the owner and such, we get the replication for free because we are only sending state. And the animation graph, the values that are set there, they also get replicated automatically for you. And there is actually a custom setting that you can have. For example, if we go to the animation graph, we go to the controls. When you're modifying it, it says if it's going to be synchronized and all that. This is what is going to allow it to be synchronized nicely. So if you don't have it set up, then the variable is set to not be synchronized. So if we were to, for example, run dedicated server tool with another peer, we should see the effect of a client character reloading this way to also affect and be seen on the other client. So let's create a new peer config. It's basically going to be the same. So let's just copy the configuration here and paste it here. And let's just make it so that the port is different. Let's make it 555 and then run. This is going to run the two clients now. And we should be able to see like the logic involved. So let's make sure that we got the things here. So here we should see it on the left whenever we reload, and also on this client. See? Performs as expected. So that's basically it. Like once you understand this part, it's a little bit easy to like get along with the things, to understand like what to do. When it comes to items, vehicles, and all that, they kind of like do it in the same way that this is just that the animation class is different, as you have seen here, because sometimes for vehicles you need different logic. So you will have another class here that is not the weapon animation component, for example. So you search for animation and then you will be able to find it. If you want to see, for example, all the components that are animation components, just go to the base class here, animation controller component, right click on this, and then see derived classes, and then you can see all the other ones. Just in case that you don't see the proper component in the prefab. It might just be named something that doesn't have animation on the name. So this is one way to see it here. There is a more advanced way of doing things as well, which is the scripted components. But this alone will require another bootcamp, so this will be a little bit outside of what we're going to explain today. But it's basically the same. It's just that instead of handling the things through the game game commands, you can also make your own custom command where you can make the character or the whatever entity do exactly what you want without anything interfering. So if you wanted to create, for example, a completely custom character controller, then you could with the scripted commands. But this one, it will probably be tutorial that will release later on, as it's more advanced. And it's more prone to confuse people how to do things, and it's more common to just see it with people that are hardcore scripters. So if you don't know scripting too much, you are not too keen on programming, then messing with the custom commands, it might be too much. So that's it. Hopefully it was not too much. I tried to explain as much as possible in that time frame, but without making it too like overwhelming. But hopefully it's fine. Thank you, and see you in the next one.